Hello everyone, this is Muhammad Mehraj Hussain 12008005. I have recently completed my bachelor's in computer science and engineering from Comilla University and currently pursuing my master's in computer science and engineering at Comilla University. This video is being recorded as part of our deep learning course where we are exploring fundamental challenges in deep learning. Today in this video, I will be talking about the vanishing gradient problem, what it is, why it occurs, and why it is an important concept to understand um, when working with deep learning models. So let's start. Vanishing gradient occurs during the training of deep neural networks, specifically during the backpropagation. In this situation, the gradients become extremely small as they move backwards through the network. For this, the earlier layers of the deep learning models learn very slowly, or sometimes they stop learning at all. As a result, the model fails to take advantage of its depth. To understand how the vanishing gradient occurs, we need to have a look at how backpropagation works. I assume that we all know how backpropagation works. During backpropagation, the gradients are calculated using the chain rule, which means the gradients from each layer are multiplied together as they move backwards through the network. This repeated multiplication can cause the gradients to shrink rapidly. A simple way to understand the vanishing gradient problem is through the simple multiplication. If we multiply values that are less than 1, such as 0.5 or 0.1, then the product converges to 0. Similarly, the repeated multiplication of gradients less than 1 keep the gradient values shrinking. As a result, the earlier layers cannot learn, or they learn very slowly. The key reason for this lies in the activation function. The derivative of sigmoid activation function is always less than 1. So for this reason, the gradients keep shrinking when they pass through the network, or layers of the network, while the derivative of ReLU is either 0 or 1. When it is 1, the gradient can pass through the layers of the network without shrinking. So this way we can solve the vanishing gradient problem initially. Although using the ReLU cannot solve this problem completely, there are some other methods that could be used to solve this vanishing gradient problem, like reducing the complexity of the model. So thank you everyone, that's all.